Hello, everybody. Welcome back to this video. And here we are going to discuss about some properties or desirable properties of transactions. So in the previous video, we have discussed about we have seen what a transaction is and how the instructions in the transactions will occur. Now let us see what are some of the desirable properties which should be satisfied by transactions. So in this video, we shall discuss about failures and why recovery is important. Recovery from failure is important. Then we shall look at the states of a transaction, and then we shall discuss about the desirable properties of transactions. So, failure in a system can occur because of so many causes. You may have a system crash, which is a computer failure. There can be a transaction or system error. So some code in your transaction, some instructions in your transactions are not written properly. So that can lead to a transaction error. They can be local errors or exception conditions, okay, which are detected by the transactions. Like suppose you are trying to withdraw some money and you don't have sufficient balance, then the transaction will detect this exception. There can be concurrency control enforcement. So as we shall discuss in the coming video, concurrency control can also lead to some instructions of a transaction not being completed because it violates these rules or concurrency control rules. Okay. Then there can be things like even disk failure, the failure of a particular hard disk has failed where your data is stored. And there can also be physical problems like fire or say a flood or some kind of a physical catastrophe. So because of all of these things, it is not possible, it may not be possible for all the instructions in your transactions to execute completely. And if you can recall from the previous video, I had mentioned that a transaction, all the instructions of a transactions will execute either completely or it will not be executed at all. So if there is a failure, okay, the system needs to keep track of when the transaction starts, terminates, or commits or aborts. Okay, so let's look at the various states of a transaction because we need to recover from it. We need to recover, failures can occur, and we need to recover from the failure. So for recovery purposes, we have to keep track of the states. So a transaction has a start when it begins, an end when it terminates, and then there are two more things. One is commit and the other is abort. Commit is when all the instructions of the transaction have been executed and all the data has been written to the database and everything is done properly, and that is when we say that that is the commit point of the transaction. So all the instructions have been executed properly. An abort is when there is a failure and it is a signal to abort the transaction, to stop further transactions from executing and to roll back the previous instructions which had been executed. So a transaction has start, end, commit, or aborts. So based on this, we can look at the transaction states as the following five. So first of all, it's an active state. Then there is a partially committed state. Then there is a committed state, or then a failed state, or a terminated state. Let's look at this with this diagram. So here we have a diagram which shows initially when the transaction begins, okay, when the transaction begins with the begin transaction statement, it goes into the active state. The transaction is in the active state. So as long as it is performing some operations, read, write, and all these operations, it remains in the active state. Now, when it reaches the end transaction statement, that is, everything has been done properly and all the instructions have been executed, then it comes to the end transaction. So when it reaches the end transaction, it goes from the active state to the partially committed state. Okay. Now, in the partially committed state, all the instructions have been executed, but the data has not been written back to the disk. So only after commit is performed, only after this the transaction commits to the database, then it is converted from the partially committed state to the committed state. Okay, so once it is in the committed state, now it can go to the terminated state. It goes to the terminated state. So if everything goes well, the flow should be begin transaction, it goes into active state, it performs all these read writes, it remains in the active states, it completes the execution of all its instructions, so it goes to the end transaction, then it goes to the partially committed state. All the database changes that the transaction has made has been written to the database, then it goes to the committed state, and once the data has been written to the database, it goes into the terminated state. Now this is if everything goes well. Now, as we have mentioned, that it may not be the case all the time. So while performing read and write, there may be a failure, and then you may get an abort. You get an abort. So while it is in the active state, in between, it may go from active state to a state called the fail state. So in the fail state, it is never committed. As you can see, there is no path from failed to committed. So if it is a failed, if there is an abort signal, then from active, it will go to your fail state. Now, the failure or abort can occur even after all the instructions are executed, but before the data has been committed, before the commit. So when it is in the partially committed state also, because of an abort, it can go to the fail state. Okay, and once it goes to the fail state, from there is only one state where it can go, that is the terminated state. So to the terminated state, a transaction could reach the terminated state either by when it has executed successfully, that is via this path, okay, or if something went wrong, then it can reach here via this path. Okay, but one thing, if you see that once the data once it is committed, once the state is committed, it cannot be failed, it cannot go to fail, or from fail it cannot go to the committed. So this cannot happen. So if a transaction commits, means it cannot be rolled back. Once it is failed, if it is failed and terminated without commit, then there are ways by which we can roll back the transaction and undo the operations performed by the transaction. Now, those were the states of your transaction. Now, let us look at the desirable properties of a transaction. So there are 4 properties which a transaction must possess. So these are called, the acronym is ACID properties, ACID. What does these stands for? So A stands for atomicity. Okay, atomicity is, what is atomicity? A transaction is treated as a single unit. That is, it either completely or it either completely entirely it is executed entirely or not at all. So either all the instructions are executed or none of them are executed. So that is what we mean by atomicity. So the first property of a transaction is atomicity, which states that this. So for example, if you have a bank, you're doing a bank transfer of 1,000 rupees, is debited from your account, and you're transferring some money to account B, but the amount has been, let's say the amount has been debited from account A, but it has not been credited to account B due to some error. In that case, the uncredited money should go back to the account A. So in that case, the entire transaction is rolled back, leaving both the accounts unchanged. So A will remain with 1,000 extra and B will remain without that 1,000 transferred. Okay, so that is a atomic property. The second C of the ACID stands for consistency. Okay, so what does it say? It says that a transaction takes the database from one valid state to another valid state without violating the integrity constraints. Okay, so always the database state should be consistent. Okay, and it should never, like for example, so if there is a a rule in the bank which says that the total balance of all accounts must remain the same during a transfer, then even after a transaction, this rule must still hold true. So if account A and account B, total amount was 5,000. So we are doing a transfer. This as 4,000. This is 1,000. We are doing a transfer of 1,000 from A to B. Okay. Then this will become 3,000. This will become 2,000. Total is still 5,000. Okay. So this is it is moving from one state. Total money remains the same after a transaction. So this is consistency. It is moving from one consistent state to another consistent state. The third is isolation. ACID. So I stands for isolation. So we have seen that the transactions, they occur at the same time in an interleaved manner. But this interleaving of instructions of transaction should not interfere with each other. Okay, it is not that who will execute first will get a different result, and if T1 executes first, we'll get a different result, and T2 executes first, we'll get a different result. No, it should not affect. It should be as if T1 is executing alone and T2 is executing alone. So transactions occurring at the same time should not interfere with each other. Intermediate results of one transaction are invisible to the others. Okay, so that is isolation. So if two users are booking the same train seat simultaneously, only one should succeed based on proper isolation. So only one should be able to book the ticket. And the last property is called durability. That is, once a transaction is committed, the changes are permanent. You cannot roll back. Even if the system crashes up immediately afterwards, you cannot make any, it cannot be rolled back. Okay, so that's why commit point is very important, because commit point means that all changes have been written to the disk, has been made permanent. So the transaction should ensure durability. So for example, after a successful order placement, the order details should be stored in the database, even if there is a power failure. Okay, so these 5 properties that we have seen, atomicity, consistency, isolation, and durability, these 4 properties make sure that your transactions that are handled will be robust, okay, will be reliable, and it will be secure. So you should not get you're using a banking software and then you should not get a heart attack by looking at the transactions that are there. So these transactions should have the ACID properties. These are the properties that they should possess. So this makes your system robust, reliable, and secure. So these are the various properties, desirable properties of transactions.